So in this video, we're going to learn about a first type of sequences. There are going to be two sequences that you're going to learn. The first is arithmetic sequences. Your objective is that I can state whether a sequence is arithmetic, and you can write the explicit rule for arithmetic sequences. All sequences will have two rules. You're going to learn the first one, the explicit rule, today, and in the next video you're going to learn about the recursive rule, which is the second way to write sequences. So all arithmetic sequences is a sequence when each term changes by a constant difference. It goes up and down by the same amount. So these are examples of arithmetic sequences. If you look between, what is the common difference between each of them? Well, 3. You're going up by 3 each time. On this one, it's not going up, but it's going down, and it's going down by -5. So all arithmetic sequences go up or down by a certain amount. These are examples of non-arithmetic sequences. If you notice here, it's going up, but it's not adding, it's multiplying by 2. So that's not. They have to be adding or subtracting. And this one, it looks like it's going down by 1, but they're not the same difference between them. Like this is a half, and then this is 1/6, and so forth. Non-example is example. So really it just goes up and down by the same amount. So I said all sequences, there's two rules to write all sequences. The first one is the explicit rule. This is a formula or equation that allows a person to calculate any term in the sequence. So this is an example of the explicit rule. Remember, a sub n means what term you want. N is the number, and then 6. So if I want to calculate a sub 1, my n is 1, so I go 3 times 1 plus 6. 3 times 1 plus 6 is 9. So if I want to calculate a sub 7, now my n is 7, so I'm going to go 3 times 7 plus 6. 3 times 7 is 21, plus 6 is 27. And then so forth, a sub 20, and you might want to do this one on your own, is 3 times 20 plus 6. So 3 times 20 is 60, plus 6 is 66. We use these to write our sequences because we can just keep plugging in numbers to get each one. So they always start off with a sub 1. So I can plug 1 in for n, and I get 3 times 1 minus 5, so my first term is -2. Then I need to find a sub 2, which means what is my second term? So I plug in 2. Instead of 1, I now have 2. 3 times 2 minus 5 is 1. Then I find a sub 3. Plug in 3. 3 times 3 is 9, minus 5 is 4. And lastly, a sub 4, which would make my fourth term. 3 times 4 is 12, minus 5 is 7. So my first 4 terms of the sequence are -2, 1, 4, and 7. So on the second one, you might want to try this on your own and then see if you are correct with me. You have a sub n equals 1/2 n plus 4. So again, I need to find the first 4 terms. So I plug in 1 for n. I get 1/2 times 1, which is a half, plus 4 is 4.5, or 4.5, however you write it. Then we find a sub 2. A sub 2 is, instead of 1 here, we now have 2. Half times 2 is 1, plus 4 is 5. We find a sub 3. Half times 3 is 1.5. Plus 4 is 5.5. And then a sub 4 is half times 4 is 2. Plus 4 is 6. So these are my first 4 terms of the sequence. Alright, so how do you actually write these rules that you're seeing? So back here again, these are both explicit rules. Just kind of an equation to figure out the terms. So how do you actually do it? Well, up in the right hand corner, this is very important to note. I'm going to highlight it. The a sub n equals dn plus a sub 0. So what does this all mean? Well, d is a common difference. What do you add or subtract with each term? N is the number term in the sequence, so that's what we plug in. And n we don't change, it's just going to stay there. So we really need to figure out what d is. We don't need this, actually. But a sub 0, the term before the first term in the sequence. So a sub 0, everything always starts with a sub 1. So here 7 is a sub 1. I want to know the one that comes before it, if you would go before a sub 1. And that's what goes here. So let's look at the examples. Right here, first I need to find my d. What do each one go up by? We can see that you're adding 4 each time. So 4 is my d. So this equals a sub n. My d is 4. N stays, that's your variable. Whoop. Erase that. So now we need to find a sub 0. Well, this is a sub 1. A sub 0 is the one that comes before that. So if I go this way, I add 4. This one, I subtract 4, and my first term is 3. So again, a sub 0 is what becomes before the first term. So that's your explicit rule for the first one. So let's take a look at the next one. And a lot of you guys might be discouraged by just looking at fractions. However, if you don't like fractions, make them decimals. So 7 over 2 and 3 over 2. 7 over 2 is 3.5. 3 over 2 is 1.5. This is negative 0.5. And this is negative 2.5. So it might be a little easier to see what is going on. What is the difference between them? Well, hopefully you can realize they're all going down by negative 2. You're subtracting 2 every time. We added 4 this time, we subtracted negative 2. Alright, so I can write my explicit rule, which is a sub n. My common difference is negative 2. We put n because that's where we're going to plug in to find terms. And then I need a sub 0. So what came before 3.5? Well, 3.5 is 5.5. So either here you can go plus 5.5, or you can write it after the fraction, which would be 9 halves. Alright, so last examples is that you need to write explicit rules for the nth term of the arithmetic series based on this information. So remember, your formula is a sub n equals dn plus a sub 0. Alright, so your difference is 4, and your first term is negative 6. So let's look at what the sequence would look like. We know we have negative 6. Our difference is 4, means we're going to add 4, so the next one is negative 2. And then it would be 2, and 6, and so forth. So if I want to get a sub 0, which is before the first term, I need to go the opposite way, so this would be negative 10. If I add 4 to go this way, I need to subtract 4 to go that way. So my answer is a sub n. My d is 4. N, and then a sub 0 is negative 10. Alright, so on B, I have d is 2, so my difference is 2, and then I don't give you the first term, I give you the fifth term. So a sub 5 is 9. Well, that means a sub 4, if I want to go this way, I add 2, that's a sub 6, This is 7. 5 is a sub 3. And then 3 would be a sub 2. 1 would be a sub 1. And then negative 1, this would be my a sub 0. Okay, so we're at 5. This is the fourth term, third term, second term, first term, 0 term. So to write my rule, I'm going to write a sub n equals 2n minus 1. Alright, so your last example, now I have a sub 8 is 16, and my difference is 20. So my 8th term, a sub 8, is 16. If I want to go this way, you're going to add 20. If I want to go that way, we're going to subtract 20. So I just need to keep subtracting 20 until I get to a sub 0. So if I subtract 20 here, I get negative 4, that's 7. This is negative 24, negative 44, we run out of room. So that's 7, 6, 5, 4 is negative 64, 3 is negative 84, 2 is negative 104, it's negative 124 is 1, so the last one is negative 144. Okay, and we can count to make sure this is the 8th term, 7, 6, 5, 4, 3, 2, 1. This is a sub 0 right here. Alright, so to write my rule is a sub n, my difference, which is 20, n, and then it's minus 144. Alright, so to review, arithmetic sequences are only when they go up by a constant difference. You either add or subtract. And then make sure you have this down of how to write the explicit rule for arithmetic series. Alright, reminder to do a reflection to get credit for watching this video.